in back. Okay, now you see, the ECAD stuff. The reason why this is working is you have libraries behind the whole project. We have taken the components from what we have done, bringing them into schematic and in the board. And of course, Eagle has a lot of libraries. We have seen this in the control panel. We have a number of managed libraries coming with Eagle. But of course, that's not all. You will definitely come to a point where you say, this device is not available in an Eagle library, I have to create it. Maybe from scratch, maybe you want to copy something together, or you pull out the footprint from a big library and draw a symbol for it or something like this. That's that's something that's fundamental for the work. So in creating library, there you have to be very careful. Don't make the chaos I have done now in Fusion, because as soon as you have a component defined, it has a name, the symbol has a name, the package has a name, it comes from a library. Think how you name the stuff, because as soon as you bring such a component into the schematic, the full definition is in the schematic. And everything refers to this library, to this device name, to this symbol name, to this package name, to this 3D model. If you now decide one day later, I have to change the names because I should have named it test 11 but test 12, that doesn't make sense. And then you can rename it, but you lose the connection between schematic and library. You don't need it. But if you want to do some changes, you would like to add something, or you want to replace your components because you have a newer version of the component, because you decided, I don't want to have my name texts in this position, I want to have it anywhere else. Then it doesn't fit together. And then you have to delete and add, and the whole mechanism, library update, for example, does not work anymore. So that makes things not undoable, but more complicated. So that's one of the things you really have to take care of. And if you define a footprint, that's what we see in the board. Think of the sizes. This must be precise, because the package must fit onto your footprint on the board. If this doesn't fit, then it won't work. So that's very, very critical for the whole electronic design. So basically, a library consists of, just let me open one of mine. It's a simple example. It consists of a device. And the device has, wrong. It consists of a symbol, it's something like this. That's what we use in the schematic. We have pins where we connect the nets. That's the symbol here. And we have packages, footprints. I have to get used to footprints because earlier versions we talked of packages. That's the footprint here. So that's the size of the soldering area, that's the SMD, the distances. This must be accurate, so you have to be careful. That's the one thing. And we combine symbol and footprint into a device, so that Eagle knows, if I go here, for example, if I want to connect a net with this pin here, then Eagle has to know where to connect there in board, because you transfer the net information into the board. So this must fit. I looked into the data sheet of the manufacturer, and they say the input voltage goes to pad 5, for example. That's written here. That's what I have done here. So it's also important to remember or to name the pads correctly, place them correctly. So that's something you have to be very careful with. And the next step, of course, is yes, I would like to have a 3D package. This one, this one. How do I get 3D packages? You could design it in Fusion, for example. This is an option. But in most cases, the manufacturers have 3D models. If you go, for example, for connectors, most manufacturers offer the step models in most cases for free. And there are different sources in the internet where you can download 3D models for all kind of electronic components. 3D, what's 3D Central, for example. There's some more where you can download 3D step models. And of course we can create them. We have the footprint generator, that's something new, which is, it's still, it will always be limited, but it's pretty limited at the moment because there's sitting some guys and you have to support different kind of components. If it's a BGA or is it a component SOP or FPGA or PLCC, whatever. So we have all different kinds, and we are implementing more and more stuff there, so it's more convenient for you. That's the easiest way. Use the package generator. It generates a 3D model and it generates a footprint. So that's the perfect way if it fits for you. And if it's okay that it is working with the IPC standards. So, okay, so where to begin? I think we take the easiest way first and make the complicated later. So, a word before we start here to the managed libraries. If somebody asks you and say, hey, I have this Conf4, whatever this UConn library, it's a managed library. You see, I can't edit it. It's not allowed to edit managed libraries. If I compare it to my libraries, my own, they are not managed in this case, I can open it and I can edit it. Why? We don't want the customer to mess up the managed libraries. Because you get a package of libraries if you when you install Eagle, and we, of course, from time to time update them. At the moment you get updates with new 3D models linked into the libraries. And if we would allow to the customer to edit the libraries, then you get a mess. This would work. So if somebody wants to edit one of these libraries, the managed libraries, he could copy it. So it's an unmanaged normal library, and then he can do what he wants. He could again make it his own managed library. That's also possible. So it would work as a managed library. Okay, but usually we say, don't touch our libraries. There are some guys, of course, the libraries are stored on the computer. If you know where, of course, you could change them. And I had guys that do this, but they don't have to complain afterwards if something is missing. That's not my problem. So leave them as they are. And we have a lot of people, as I said yesterday, they don't use these libraries at all. They don't want to use them. They make all by themselves. Because then they know, okay, that's I've done, and if it doesn't fit, I know where I have to go to and kick him in the ass. That's my own life. So, yeah. And about the, perhaps before, about the library updates we have. If I'm in the board or in the schematic editor, I have the library menu, and there I have the library manager. If I open this one, I have a list. Here you see the tab InDesign. Eagle tells me I have components from these two libraries in my design. It's just more information. The interesting thing is what is in use. This is the list you see. Yeah, that's what we also see in the control panel. I have all the libraries in use. You see it here with the I can't switch because this is not this one. You can see all the green dots say this is in use, so it's available for adding something. And that's the list here I see. I can also take the library manager and click onto one of these and say, okay, this analog device library I do not want to use. I can remove it from the list. It's not deleted, it's removed from the list. If I do so, it's gone here and should also be.
Yeah, just down a bit, and just say it went from green to black. A little while.
Yeah, here it is.
Yeah.
As you see, yeah. So I have to upgrade like always. So that's the same way. And I can look what is available. No, let me scroll up and down. At the moment. If there would be no, don't see no updates at the moment. There's one. If you get something like this, then NGS isolation. Okay, this would mean there is a newer version available. In this case, it's version 16. I could select it and could update it. What happens if I say update? Eagle simply downloads the new library, replaces the old one with the new one, and it's available for you from now in the new version. What's available? So we have additional libraries that come not with the package. Mostly, yeah, at the moment it's Seed and SparkFun, and some of Wird Electronics has some libraries contributed. If I say I want to have this one, I could simply download it again. It means use. If I say use, it will be downloaded, it's in use and it's available for you to use it in the schematic. So that's basically what we have. You see here back in use, for example, some is the version, and there is one, it's the DC-DC, it's my library, that's my own managed library. I have version 3 and I have some edits. What I did is, it's a managed library, I opened the library, it's my own, I can open it, and added maybe a tuple or something like this, and then it tells me the local library has 3 edits that are not pushed into the cloud, so it's not synchronized. Not so critical at the moment, but that's something maybe something you did not do when you tried to do this. This could, that's not, the workflow is quite nice, but it could be better. It's not obvious what to do. And so there we're working on that. This will be a bit easier, because you know where to click, where do I have to click to get this updated. And that's, if you don't do this, then you have a bit of a problem. Yeah. Okay, that's the library manager. Let's go to the library. That's my home. Okay. Normally there's nothing inside. So what? Yeah, we want to create something. Let me check. What shall we do? Edits. I'm making a library. That's better. No, that's wrong. Oh man. File. Library. That's what it was. So, nothing inside. If I know what I want to do, then I could use, that's also, here it's not obvious what to do, because I would like to create a footprint now. Where would you click to? I can say add footprint. But that's not what I want to do. I want to use the package generator. I have to go this way there and say create with package. That's the interface could be better. But okay, I simply show you. I say I want to have a 3D package plus footprint for a component. Normally you would have a data sheet. Okay, I have to look for a data sheet. But just here in advance you see we have different options what you can do. You can do also create through-hole components, axial things, BGAs, chips, chip arrays, so different kinds of components. And that's something we are constantly improving and adding more stuff to it, because there's so many different components. It's not so easy to have everything at once, so that's the last thing. So let me check for a data sheet. Document. There must be something in there. these data sheets. Step models, I downloaded some from the internet, and let's take, I take the LM2840. Interesting. No, it's not okay. That's a data sheet from manufacturer. It describes what does this thing do. Here also you see a symbol, it could look like this. Then you scroll down, that's the package. But anywhere there must be some, typically it's the end of the sheet, there we will find, this one. This is what we need. So there I have my data sheet. Now I have to go into the package editor. Now I have to search for a fitting component. I think it's a kind of SOT, something like this. And then I have to fill in all the stuff here. So that's a bit. Let me move this, make this one smaller. So it's sorry. Okay, so what we can see is how many pins do we have? 1, 2, 3, 4, 5, 6 pins. So I say 6 pins. You see I get the pre-selection. Then the pad shape, is it rectangle? It could also be rounded, it could be oblong, different shape, also options. This rectangle. The density level, that has to do with the IPC standards. There's the 3 options, normal, most, and least, so it depends on the density of the board. There are bigger or smaller landing patterns. At the moment you select 1. In the future we will simply create all 3 in 1, and then you can decide which model I would like
I
to
think that in the mental graphics you can choose the smaller and the larger variants of them.
Yeah, that's not yet possible. So here I have to create this or that model. But as I said, we will be working with that you get all 3 in 1 model, and then you can decide I take this or that. So there's no variant at the moment, but we will have this. Okay, let's leave it as this. Then we have E. What's E? I have to look here. So that's the pitch from here to here. That's exactly that what we have there. It's fitting, yes, of course, it's the same kind of component. So then we have E. E is this one. It's here, it's 255 to 305. It's quite interesting, the differences there we have. So that's what I type in, minimum. 3.05. No, that's the smaller one, 255 millimeters in this case. I can also change the units here if I want to, if the data sheet is in inches, something like this, so you don't have to recalculate this.
It's interesting that those columns are not obvious that it's the min-max.
The min-max, that's not obvious here.
Right.
If you would do it the other way around, okay, if you click, if you hover the mouse and it says it, and if you would change it, you get an indication. If I would type 4 here, okay, you don't comply. Okay. The jury disregards my last sentence, so whatever it is. Okay. Yeah. Okay, next one, L. What is L? Sometimes we have the lucky situation that the letters are the same as what the enter. It's L. What is L? This one. This should be 30 to 60. Next one is B. What's B? That's this. It's 3 to 5. No, I didn't. Okay. Then we have D. What is D? This like here, 2 0 simply use the tab.
Yeah.
Jump from one thing to the other. A, say, R8. Not visible here. I don't know.
1.1.
It's 1.1. The maximum, yes, would work. That's okay. So yeah, 10 here. Leave it with 1.1. Okay. Yeah. Could do it now this way. 1.1. So it's the same size one. And A1, this was this one. I have here. I've seen it. Yeah, this one. Okay. Then we have match silk screen the body, so I could decide the size of the silk screen around the body, bigger or the same or less size. Normal fabrication tolerance, that's something mentioned to 0.2. I think that's not really important here, but yeah, then let's click update preview. Now generate the model for us. Here we are. So that's the model. See, I can see here. I can also switch off the board, so I can look here. I can also sometimes it makes sense to remove, increase transparency, so I can look through it. Yeah. Okay, that's it. Done. If you would say, I want to have the most update, you would watch the so it's bigger. So that's the differences you see. The least one is of course smaller. Yeah, here it is. Depends on what you want to have. As I said, in future we will have all three variants in one model. Okay, so that's it. I've done. I'm done. So I would pick here finish. Now, Eli says you will create a packaged version, create version 1, save it, create the footprint, download it.
So is that doing the footprint and the 3D model?
Yes.
Both?
Yeah, you get that. Yeah. That's very convenient, of course.
Yeah.
Now downloading the package because I need it in my library. And if I move the library window up here, you see I have my footprint. So I don't have a preview yet. This will be done. The priority is not so high there, but now we have it. That's it. Yes, these two now fit together. Easiest way to have both. So, but of course, the packages you can't use this because think of connectors and so on. So that's something you might really have to draw in the footprint, and yeah, that's.
But that did resistors and passives as well, by the looks of it.
Yeah, we can also let's try a resistor. The package creator. So I simply will use random values. I go Excel. I can define what is it, resistor, capacitor, it's a polarized capacitor, a diode, if you use a capacitor, polarized for example, then it's a pad shape round, what is B, yeah, that's the diameter of the wire here, then some sizes, I simply say update preview. There we go. So that's something okay, nice. I could also change it, then also the polarized, it should be non-polarized. I don't know the difference. I think it's obviously the color. Yes, correct. Yeah, so it's a simple, I could also say it's a resistor. Look, yes. We will also soon have an option to have some lettering, some wording on the resistors.
Yeah.
That you know what it is. Okay, so that's it.
That's very quick, isn't it?
Yeah, finish. Of course, I could also use make SMBs. That's the same.
Sure.
Yeah, the same is. So, if you create a standard library with the most common components, the way to do it this way is quite.
Much better off starting from scratch than trying
Yeah.
to
Of course you have to draw a symbol, but the symbols you
Yeah.
can simply pull from the other
Yes,
partners.
you can keep existing
Yes.
symbols and just,
Yes,
yeah,
correct.
yeah.
Or you could also, yeah, show you. Okay, so yeah, the names are a bit long, that's the IPC names, but you could rename it if you want. You could go inside and say, rename it,
Okay.
um, or
Test 12.
something like this.
Yeah.
It's linked,
Sure.
this fits together.
When you get into manufacturing, then quite often companies will have their unique supply part number there for their bill of materials.
The unique supplier part number is something, if you want to work with them, you could define attributes and make it, but then you need a real, I think a series of resistors with different values in the library. Our resistors have no values, so we say that's a resistor and you decide what it will be. And then you could also have the attribute, the MPN there. Then you have to fill in the attribute with the correct number. That's the one option, or you really make a, what is it, a complete series of resistors with all the values in it. Or you could use them as, yeah, I would do it. You could also use technologies in the library. So the value is the technology. I have one device. This device has several technologies. 1 kilo ohm, 10 kilo ohm, 100 kilo ohm, whatever it is. Then I have a kind of matrix. And I can have MPNs for each device variant in this device.
Yeah.
That's also possible. Okay, maybe I can show you that. Okay, so we have easiest way to create footprint and 3D package. What else? We need a symbol, of course. I say add symbol, and I could import now from another library. I say import, I get the list, I know RCL has a resistor symbol. I take the C, no, it's the C. Say okay. Here it is. So that's the easiest way.
Yeah.
Of course, I want to show you then how to create one, but that's in the library editor we have here some icons you should know. We have different modes now, and the symbol editor mode that's seen here in REU.sym, that's the symbol. I can go into the table of contents, that's the kind of overview what's in the library. I can go directly in the symbol editor mode, clicking here. There you see that's the REU I have inside. I say okay, and now I am again here. If I go back, the easiest way is simply to double click or do a right click, and then I have certain options on there. And now let's create a device just to show you. That's something I have to do directly in the library. I can't. Yes, also sometimes it makes sense to copy that. I say add device. Now in this case, I want to have a device name. Here again, username. That's really. This will persist for the next 100 years.
Is this the preferred sequence? So you do your package footprint, symbol, and then add device as the last stage?
That's my preferred way. Yes, you could. I think
You can't have your device and you've got the other bits done.
the last step would be to create the device. You could even, there is also an option to say I create the device. I must have a symbol before. I use the device, I add my symbol, and then I could, in the device editor, say, okay, now import a package from anywhere. That's also possible. But yeah, my preferred way is first the package, then the symbol, or first the symbol, then the package, and the last step is the device. Or you, let's take the same way as I see. Okay. Okay. Want to create? Yes, of course, that's a question. Not like so. Now we are in the device editor mode. You see here, .dev for device. Yes. Now I have to add my symbol. You do it the same way as you do it in the schematic. I have the add command. And what I see now is, once in the library, there's only one symbol we have to create this one. I select this one. Say, okay, here it is. And I can place it. That's it. There's the next symbol on the mouse cursor. There are some devices, think of some gates named and or gates, whatever, where I can have several part symbols. That's then what we call a gate. Or sometimes you see power pins of a component not visible in the schematic or maybe placed anywhere else. So a component can consist of several symbols, which is a gate that we're speaking of a gate. Or think of a connector. You have 96 pins you would like to connect. There are different options. I could decide now, do I want to have one pin after the other placed? Do I want to have all in one piece? Should they be movable? So there's something, we call it add level. I can decide here what happens. I will show you maybe later. Just if I use the display command and use the pins, there is a bit information about the add level. Next is the default setting. There are different options. I explained it a little bit later, that makes not sense here at the moment. But okay, this one, okay. Next step, I of course need a package. The right hand side, that's more for the packages here, and there I can click on to new. What's new in here, I can also click there. I could also decide now and add a local package, or add from it. That's the same as we had in the beginning. So with the new versions, you could also start here and say, I create a device. I have already there, I have a symbol, but I could now start creating the packages. That's also possible to do here directly in the device image. In this case, if you say add local package, that means look in my library. What do I have? I have these two. I select this one, say OK. And it's there. It has no variant. I didn't take care. Let me get out of this. Yes, I can. I click new again. Set a local package. Select here. Please look here. You can define a variant name. If it's only one variant, then it's not a problem. Think of our 555 from yesterday. It was available in the DIL case, through a mounted or a surface mounted device. Then I have to decide the variant names. We have the LM555D and the N. N is typical for zero, D for whatever. You have to name it here. I leave it as it is because I decide only to have one in this case. Sometimes the resistor library, you see the package variant, the number of the package, it's 02 or 4 or something like this, so this could be the variant name here. Okay, there it is. So, and then you see this small sign. This means we have not yet assigned pins and pads. And that's what I'm doing basically here, or maybe even with the right click, I can use connect. Then I get a list. You see I have pins, that's pin 1 and 2. And they have pads 1 and 2, 1, 2. And here it's not critical how to assign, but if you have a more complex component, then of course you have to look in what belongs to what. G$1 stands for gate number 1, so that's an automatical naming. If you would have more gates, you probably would name the gates A, B, C or something like this, so that you can distinguish them in this configurator. And I say, select this, select that, and connect. This are selected and connect. Both are here. I say OK, green tick, connected. Then next step, we typically have a prefix. Resistor R. So that's for the automatic enumeration, R1, R2, something like this. Diodes have D or IC or U for an integrated circuit. So that's this one, and then I have here value on or off. What does this mean? Value off means the value is not user definable. It's a bit crazy. You have to think around the value word that come from behind. Value off means the user is not allowed to define a value. This would be typically the case if you have a LM555, because the LM555, that's the value of the thing, and the device name is the value. Usually, if you set it off, if you set the value on, this means it's user definable for the resistor, as we have it in our libraries. You get the resistor, it's named R1, but you have to decide the value. Is it a 1 kilo ohm or 10 kilo ohm? So that's what I can see. Okay. So I will switch it to on in this case because it's user defined. Yes, that's it. A bit more, you could do some description. It's always good to have a descriptive text in the libraries to see what do I have there. Maybe I can also add a link to a data sheet or something like this. If I do description, I get an editor window divided in two parts. The lower part is the editing part. I can use XML text, now HTML text, for bold and for links and so. If you look into the help, there are the supported HTML tags. So I could do a, I don't know, bold store layout. Okay. Resistor hook. Yeah, now. Something like this. Tip / you see now it's wrong written. Then I can do, I don't know, paragraph, and write something, so go on. It's HTML. So, yeah, it makes sense to have a good description because in the add dialog, if I search for something, Eagle also can search in the description. So if I do not know what the name of the component is, maybe I know it's a crazy timer, then I search for crazy timer and then I will find it. Something like this. Okay. Good. And then we have technologies and attributes. Attributes would be something, there's nothing defined. A manufacturer part number, maybe tolerance or something like this, but I would have additional information to this component. Some put prices in, I wouldn't do this, but yeah, whatever you have, the color, if it's an LED, as a attribute color, red, blue, whatever, all options, these attributes will or can appear in the bills of materials. So yeah, you see simply additional information which helps maybe in the ordering process for the guy who has to order the stuff. Okay, well, yeah, let's add one. So, okay. Something like that. Okay, I take the German one, that's easier. Okay, there we write Andy. So, that's your thing. No, it doesn't. Okay, then I can define, is it variable or not? Is it constant? So, you can change it no matter what you have selected here. If I say it's constant, you will get a request and say, hey, do you really want to change it because it's constant? So you have all options, just a bit of yeah. So there it is. Say okay, now it appears here. Of course I can add attributes. If you would like to see the name and the value of the attribute in the schematic on the board, then you could set a text, a placeholder text with the name manufacturer. As we do it here with name and value, as a greater sign manufacturer, place it anywhere, and then it would appear also in schematic or board if you want to have this. Okay, yeah, that's it. So now we have our advice. Very good advice, please save the library from time to time. File, save as. It goes into my libraries folder. Hi. Birmingham. Yes. Something like this. Okay, let's say. So we have our first component. I think the nice thing here is the package manager. It's really cool. You get very quick components. So I think sometimes it's easier to create it new than searching for a component and then copying from it. It's really cool, and as I said, we will have a lot of improvement there soon. Then we have people working on this so that we really get a lot of things there. Okay. Do you have questions about this? Let's do it. We will meet at 12 in the lobby. Oh, you know. I didn't know. I had to ask, but told me, you know. No. Yeah. So, okay. Okay, now that's the easy part. Copying from anywhere, creating with the package generator, and now I would like to show you that's exactly what we do until short before 12. Then I would just like to show you how do I create a symbol by hand manually. So I go here, say add symbol, create a new one. It's again a test symbol. I like test symbols. This, yes. Here we are. So now we are in the editor mode. Yesterday in the beginning, just walk around it. I told you that we have a default grid in the schematic of 1/10 of an inch. And that's exactly what we see here as well, because all the pins in the libraries are in this grid. And I would recommend to continue with this. Of course, you could start and say, okay, I want to have remix, I want to have 2 minutes or 3 minutes. It would work, but it does not fit to all the other components. It's, yeah, it doesn't look good if you have different pitches for the pins, for example. It has nothing to do with the grid, of course, in the layout. It's only schematic now, what we're talking about. Keep the grid as it is. If it's too coarse, too rough, then you could use a finer grid, use half of the grid, 50 mils or 1.27 millimeters if you want to. Makes sense, but sometimes it's necessary to do. But keep this grid. Okay? And then we have one command which is interesting, you should know, that's this one. It's the pin command. And if I click on the pin, here I have a pin. And I get a number of options here. I can decide about the length of the pin, about the orientation, of course. I can do a right click, you see, in 90 degrees. I can decide about the function. That's normal pin. I can take this one with the dot, it's a kind of inverted pin, yes. And then we have a clock symbol, looks like this. I can have both dot clock, depending on your device you're building. So I can leave it as this. I can also decide about the length of the pin. The default, I think, is 2 grid units. That's normal. I could make it shorter or longer, or I could even hide it as a point. Sometimes you see it, but it's always a bit difficult to recognize really. So I wouldn't use it. Leave it as it is. Take the middle length, 2 grid units is okay. And then I can decide about what can I read in the schematic. I have a pin name, should it be displayed, and I have the assigned pad package. So I can decide should there be text for the pin name, for the pad name, for both, or no names. If you think of a resistor, then I would choose no text at the pin. it doesn't make sense to have a resistor where you have 1 and 2. That's clear, you have 1 and 2 pins, so there is no function there. If you have our LM555, I have a GND pin, then I want to see that's GND or it's V+, or I also want to see it's assigned to pad 5 or 7, so that makes the schematic more informative. So yeah, I think that makes sense to decide here. In our symbol now, I decide both. You see, it's both names. This pin name, pad name, or the visibility of, that's the other option. Of course, you can change this all afterwards, after I've placed the pin, but it makes sense to do it in the beginning, so you don't have to click again. Then we talked about directions. What is it? We have in and output pins. We have I/O pins. We have open collector pins, power pins. That's our power voltage wave. We have passive pins, high impedance, and supply pins. The supply pins are these pins where you say, okay, I know in the schematic there is the power signal ground, for example. That's a special pin. And we have NC not connected. There are components where we have connections that say, okay, so I can decide here. I don't know, I take I/O. And we have a swap level. Okay, swap level means, is this pin swappable with another pin? 0 means you are not allowed to swap it. I can have values from 0 to 254, 255. And if you have a symbol with a big number of pins, think of FPGAs or something like this, then you think about this to allow that pins are swappable. And pins with the same swap level in the symbol are swappable. If I have 3 pins with swap level 1, you can swap them. I can have other pins with swap level 2 or 3 or whatever. So these pins with the same swap level, you can swap. This works in the way that I go into the schematic editor, click on the pin swap, click this net, that net, the nets are changed. Makes sometimes, you can also use this in the layer editor. If you're routing 2 wires and you see you have a crossing, and if you're in the lucky situation, then you can swap pins, and you could do it so you avoid such crossings in the layer. Okay, so now let's place this. Place the pins around the origin, makes sense. Oh yeah, no. If I click now, the pin gets a name, automatically named pin $1, P$1. Of course, pins should, a resistor, yeah, doesn't matter. But if you have a data sheet, look here. I have pin names, this one, V, CB, SV, FB, GND, SHDN, inverted with the bar on it. You can also define this. So let's try this one. So before I place the first pin, I undo this again. I type the name in the command line. So I need a single quote and write VN. This. Enter. Now I place it here. VN. Next would be SHDN. How do I get SHDN with a bar? I use the, what is it, exclamation mark, and write SHDN and enter and place it. You see, exclamation mark says the bar. The second exclamation mark would add the bar, then you can go on writing. Sometimes you have text with the part of the name. Then I need GND. For a GND pin, I would like to change the direction to power and place it. And then I move around, type in. Then I didn't hit the enter key, sorry. Back. GND, enter. Here you are. Click. Here. And so on. Okay. Okay, no. Let's make it. Name, C, CV, also direction, whatever it is. It's also written anywhere in the data sheet.
Well, I guess you could just put the pins down and then rename them later with the graphical name command.
Yes,
Yeah.
that's also, yeah, for sure. Oh, equal option. Yes, I didn't use the single quote.
But you only need one single quote.
Yes, and I only typed in the name. If you would type in the name and the rotation and maybe the direction and the, what do we have? Yes, so all the options, then I would have to close the name to enter with a single quote again.
So with that command line, you can define all of the properties of the
Yes,
pin.
yes, I could type, I have to look into the help if I use let's go to the pin command. You see, these are the options. Pin, the name is in single quotes, and we have options, and the options are NC in. So you write this text, and it recognizes what this was.
Yeah.
What is what? So these are the options you can. I can type in pin, single quote, GND, single quote, PVR, none for the special function, middle, what one is, R0, both, enter.
Yes.
So that's basically what you could do in a script file.
Sure. Yeah. It's very powerful.
I think it doesn't make sense, but
No.
sometimes people do like to write, to type all the stuff. Yeah, it's an option. And then you run the script and then you get this built automatically. Yeah, but here are the options you can type. And that's the reason why for the name I need single quotes, because the name could be middle. And then I have to put it into single quotes to distinguish from the options.
Yeah.
Okay. Okay, I have placed my pins. Then I do a bit of artwork. I use the line command, symbol layer, draw something like this. I'm always a fan of simple things. Of course, you could draw whatever you want to. Yeah, that's it. No, that's it not yet, because we need still the text for name and value. That's a bit annoying at the moment, because you have really typed the text command. We will have, I don't know if it is in 9.2, we will have an option to have these texts placed automatically. So you don't have to use the text command, type in what I'm doing now. I use the text command here and type in name, enter. I have to choose the layer, it's in the names layer. I have to place it. Think of the alternative grid with the Alt key, place it here. Then I have to type create a value, enter. I have to change the layer, values, and place it. So that's quite tedious, because you have to do this for every symbol you define. You don't have to, but it makes sense to have a name visible in the schematic, and it makes sense to have the value there. And so that's something we will automate. That at least you get the two texts, then you simply need to move them in the position where you want to have them. Or some people they say I want to have it in the center, because I could use the reposition attributes command in the schematic, and then have the text positioned in the way I would like to do it. So, okay, that's it. This is done. That's all. Yes, if I would like to see my attribute name, I would write something like, you know the word with the manufacturer thing. Something like this. Place it anywhere. And say, okay, that also appears now in the schematic. I also could hide it or delete it later, but if I want to have additional information, then do it this way. Okay? Yeah, that's it. That's simple. Description the same as in the device. I could describe something if I want to. Yeah. And so the next step, maybe we should save the files for that one. And then I go into the footprint editor. New footprint, there's the list what we have already. Yes, here as well, please think of a reasonable name. There are some, the manufacturers say that's the component or the footprint is a QFP 100 or something like this. Then name it this way. I don't do this because, you know, I like crazy things. So I go into the package editor. And now that's what we have recently done with the package creator is much more work here. Because now you have to look into your data sheet. I show you the package again, the drawing with the now it starts, the first step, what do I need? I need to know the pitch of the components. Okay, that's 0.95 millimeters here. That's the distance between our, the pitch of things. So I have to place my SMD pads in this grid. The first step, I use this grid. So I go into my grid, set it to millimeter, makes sense here, and I use 0.95, I think it was, okay, now it's changed. Yeah, next step. Now I need a calculator. I could read that the length of, what's the length of the SMDs?
It's got the recommended footprint if you scroll down the page.
Yeah, that's, correct. There we have it, 0.6, 1.1. That's the size of my SMD I want to have. So, I need the SMD command, that's this one. Here you are. It's in top layer. The predefined sizes, you can be 99.999% sure that you will use this value that's there. So I simply say, what was it? 0.6, 1.1. So I type simply 0.6 space 1.1. Enter. Here it is. That's the correct size now. And now I want to have them enumerated. I start with 1. If I wouldn't type 1 here, the first name would be P$1, P$2, P$3. So you had to use the name command. So it makes sense to do it now. Single quote 1. I could close it as well. If I would add further options now, I say enter and I start placing it. Now what's pad 1? This one is 1, 1, 2, 3, 4, 5, 6. So first step, I start where? I don't know. I start here. 1. So you see it's named 1. The next one is 2. The next one is 3. So it automatically increases the numbers here. Yeah, first step. But now we have the problem. I have to move this. Oh, it's crazy. I can only have one grid in here. And now I see the distance from here to here is 2.7. Yeah. What should I do?
Oh, can you not set an X and a Y grid, or is it?
No, you can't.
Right,
That's not possible. That's one of the things I would like to see, but I don't have. So I'm cheating a bit. I say I place it here. 1, 2, 3. That's the next row. Now I change the grid. So it's just 2.7. Here we are. Now I take, not move, I take group. Does this work? Let's see. I use move, control right click, move it 2.7 millimeters, go back to my last grid, and move the group here. So you have to think, that's juggling around values. 2 rows is okay. If I have 4, it's getting more and more complicated. But yeah, it's doable. This keeps you young. Thinking keeps people young. Yeah, but basically that's what you have to do. So that's not so easy. So it's much easier, of course, to type a few values in this grid. But okay, that's it. So basically it's done. Now we need again a bit of artwork. What is printed on the board? I do a silk screen. We are talking here about sizes of about, what do we have? Let's see, so 3 by 3, 4 by 4 millimeters. So you have to think, does it make sense to draw a 4 by 4 millimeter silk screen around this? Yes, no, I don't know, maybe. So it's up to you what you would like to do. If you would like to do, I use the line command. I go into top place, key place, and then I draw something in a different grid again. Then I take the alternative grid. I'm not so start here and I don't know, how should I draw something like this? No. I don't know. So bar here, bar there. Something like this. I don't know. Just an indication there's a component. Or not, whatever. It should be in layer 21. You shouldn't draw something like this because you can't solder on the printed area. On the other hand, it's not a problem because all the board manufacturers would delete this and say, no, I can't have it. That's an automatic test. It will be clipped out. So it's not so critical, but you shouldn't do it. It's something. It's an educational thing to say, don't do it. Okay, so then again, if you would like to see main values, I need the same what we have done before. Text command, create name, capital letter or not, doesn't matter. Okay, you have to put it into top names. And you see, the size of the text is 1.27 millimeters, and that's something you should keep, because if it's getting smaller, you can't read it, and it doesn't make sense. So, yeah, place it anywhere, alternative grid, I place it here, and then I also want to see the value. In most cases, I define it, but I don't print it onto the board. If I have no space, then it doesn't make sense. If you have big boards, then you see sometimes the value. Okay, these times are gone. If you have a service technician who has to repair something, of course it makes sense to have maybe the value printed on the board. That's something you see. Okay, the enter key, choose the correct layer. As I said, we will automate this soon. And place it, for example, here. That's it. That's my part, my footprint. Okay, so save it. Or can I save it? Go into the tab here. What are you doing there? Yeah, that's the footprint. Compared to this one. You missed. You could have a pin 1 marker, maybe. Okay. And this one is rotated, that one not. Yeah. That's up to you how you define it. If you think of manufacturing, all the components are delivered, but most of them are delivered on reels. And it could make sense to know how it's positioned on the reel. And if I define it the same way in the library, that have rotation 0 is the same as it is on the reel. So if you thinking about mounting machines, this would immediately match. But on the other hand, you always have to do a dry run and to correct the positioning of the components. So it's not so critical how to define it. But some people like it, and they're accurate and say, I want to have it exactly as it comes for manufacturing. That depends on you. Okay. Yes, that's it. So now let's assign a 3D model to our new footprint here. That's something we have not done yet. So it's not obvious what to do now. Just let me. That's now that's the situation. What will you do now to add or to assign a 3D model? I can go there and maybe say import. Let's say add from web. If I have already a model available in my web account, I show you what happens. I click add from web. I go, now that's library.io. That's where I have stored all my libraries, my managed libraries, and I can also have all my 3D models stored there. You see I have a number of stuff here, and of course I could say, yeah, maybe this one fits, this one maybe my package is what I have done. Yeah, you can select one and say, maybe that's the correct one. This probably would fit. Just try it. Yeah, it already exists, of course. Let's try another one. Okay. Even if it does not make sense. That's a simpler one. I don't find it. Yeah, doesn't matter. I take this one just to download something. Okay. Yeah. Now I have. This doesn't make sense. Download the package now. Yeah, that's something where I struggle now. How maybe I have a step model. How do I get it into my library? And the thing is, you have to have one. And then I say, edit. That's the thing I have to do. That's crazy. Okay, now, yeah, let's go edit, because what I can do if I use this edit button, I'm in the editing mode. And here I have all the options. That's not obvious. That's a bit crazy. As I said in the beginning, the interface is not really well done. Here I have the option saying, now I would like to update a step model. Maybe I download it from anywhere from the website, or I create it by myself. And I go into my data sheets, and let's use, that's DFN, that's something different, but just to show you. Now it uploads from my computer to library.io. Okay, here we go. What's this other picture?
So you
That is
can't,
wrong.
you can't bring a
So
step.
I'm just thinking, because that's not what I wanted to show you. General, does generate. This is the generated add model. This comes from here, yes. Generate is the package creator. Upload is what we did. But it should update the just let me try. How do we get rid of this one? That's yeah. If you open this, I have to click again. That's it. There it is. What happens if you go down here and say okay? And this doesn't make sense. Yeah, of course. That's what you happened to you as well. That you didn't get this uploaded?
I just couldn't seem to link a 3D package to the parts.
Okay. What we have to do is
But it's interesting because if I was trying to do it from the footprint column, I might have gone out footprint rather than jumping over to the 3D package and using.
But I'm just thinking because I'm just thinking, how do I assign the 3D footprint to my existing the 3D package to my existing footprint?
Yeah. Because it's just putting them in sort of random.
But it's okay. These two are assigned, but great. It doesn't fit together. But you need to control. Using 3D packages. Fit
Go
there and then say that's not possible.
So images, if you've got your what you can search for visual testament.
What I'm doing wrong? Where is the problem? Great.
Tester, maybe throw like a one and which you make purchase goes up. Probably want to know to do that.
Yeah. Okay.
Because if you get thrown the code,
What you should do when
but do that
this playing around here, the problem is again, I don't have a managed library. I have some local stuff here. That's it. That's the problem. And that's the trap a lot of people fall into. And then, as it is with me, yeah, that's it. Okay, so let me go back. I will simply remove the stuff here. Yes. Got me, I don't like you. Okay, so before, that's the problem. Before we started to play around with 3D models, we have to make a managed library. Although I can handle the 3D models a bit, it looks like you handle it locally. I have to go into the managed library. But how this can be done, show you the library manual, and there's the option create managed library. That's what you have to do here. Yes, it's good to save it. Now we create this managed library. So what happens, it takes the local stuff, transfers it to library, into the cloud, and makes it managed in a kind of way. It's marked as a managed library, and then it's downloaded again. And here we are. So I have a managed library. And now you see the original library is in this path, email archive, blah blah blah, and there must be a managed one. If I look into the if I look into the library manager, it has to be done from here. There should be a Birmingham library. There it is. Yes, it's available now. Okay, here it is. Just to show you. And now we try again to assign or to upload a step file. Now it's managed. What happened? I get a 3D package for each footprint automatically.
Yeah.
There's nothing, it's only a block at the moment. But that's the step you need before. That's why I also forgot it now. And you see that's not obvious, and that's exactly the problem. Not everybody, but a lot of people fall into it and say, hey, what's now? It doesn't work. And that's something I told you we have to improve this interface.
Yeah.
But now it's no problem, because now I have footprint and 3D package. And now I click here and now I use edit. I come into the web again. Here I have my block.
Yeah.
You see? No, that's wrong. That's the one. Which one is it? Yeah, it's correct. Yeah, that's what I have designed. And And that's the block. And now I could say upload a step file for this footprint, or generate a model for this footprint, or add a model from.
So now you're going to get your step file from
Yes.
Molex
Yeah.
or wherever.
Correct. Yes. Yeah. Now I say upload step. Go there. I'm not sure. Take. No, it's not a DFM. No, it's a. That's yeah. But I could upload a nice model. For example, this will not fit. That's the reason
No,
I
sure.
fit before. Didn't fit before, of course. But I can add this one, save it, and then I have it back
Yeah.
in the library. That's the problem. As soon as you start with the 2D packages, so that's the different. But just to show you, I could use this one, could move it around so it fits. That's of course. Let's say that fits, and then I simply say, okay. Can have some comments. It's downloaded, and now I will see it here that the 3D package changed. Okay, it's not yet there. That's something, this can last a bit. I don't know, the previous that's something, it has very low priority. I don't know why it's the case. Sometimes it doesn't appear.
That's where I was getting stuck, yeah.
That's not it here.
But that's fine, once you know.
This is here. That's not here yet. What I can see now is, now you go on creating, and if you go on changing stuff or adding stuff in the library, you will have to save it. You can say, if you have done your changes locally, you say create a new version, and then it will be updated in the web again. And that's also something that you have to know that you have to click there, you have to go into this library menu and say create a version. If you would do changes online, and you are feeling not running, and you started, then you could maybe have to click on to update to latest version. Also, that's something that it downloads from the latest version. So that is something, okay, then we have to think about it. If you say create a version, you should save it. It says a new version is created, and then the same process starts. It's uploaded, edit changes, but
So it's quite easy to get lost in that.
yes, that's here we are now. We have the preview.
So if you possibly can, you want to just start with someone else's.
What important to know is the first step. If you start with the 3D packages, make it a managed library.
Yeah.
And the second step is, if you have the feeling that there's something missing or the previews are not updated and so on, then go into this library menu you see here and try create a version or update to latest version.
Yeah.
That's something that's not done automatically. You have to click on it and start it. So yeah, that's the way you have to do it. There should be some buttons here around in the interface to see
Well,
what
we
to
should
do.
almost prompt you to do
Yeah.
it at some point.
Yeah, yes, yeah. This would be, if I do a change here, let me just add, let's say add a symbol or something like this. You know, reasonable names, yes. And I add something. Doesn't matter, something like this. Okay. 1, 2. And go back. And save it. Then you have a kind of sign which says it's locally modified. That's also not enough, but you need a better indication that there is something changed. That's correct, yes. But we know this, at least our developers know it, but I don't have a solution at the moment. Okay, but so, yeah, basically about libraries. You see, you have to know what to do. It's the same in Fusion, you have to know what to do. This is something, yes, if you would have an ideal world, then it would be obvious what to do. That's very difficult to get done. So that the customer sees, or you are new to Eagle, and now, how do I recognize what I have to do now? That's difficult,
Yeah,
that's
yeah.
true, yeah. But let's see what happens. So, let's stop for now. I think it's time to